All right, you guys, my last video cut off while we were working through the example 3 problem from time. So let's pick back up with where we left off in this problem and see that we can get to our correct final answer. So we had begun here by subtracting the 8 and then dividing by the positive 4. So this had been broken apart into two separate expressions. We had that 6 minus 2a is less than 4. And then we were writing out the second one, 6 minus 2a is greater than negative 4. And these were the two inequalities that we were dealing with. For the one on the left, we want to begin by subtracting 6 from both sides. That's going to give me on the left, negative 2a is less than, on the right, 4 minus 6 is going to give me negative 2. I can divide both sides by negative 2. And then when I do that, that will flip my sign and a will be bigger than 1 or greater than 1. Over here on the right-hand side, if I subtract 6 from both sides, I'll have negative 2a is greater than negative 10 because negative 4 minus 6 more gives me that negative 10. Then I'll divide both sides by negative 2. Dividing by a negative will flip my sign, so I'll have a is less than 5. Because we can be both bigger than 1 and less than 5 at the same time, I can write this as a compound inequality, where a is in between 1 and 5. If I were to graph that on a number line, I can find 1 and I can find 5, and I will have open circles at both of those values. So then I can just shade in between those two terms, and that would be my final result there. Let's take a look at one more special case of what we can encounter when it comes to inequality work. So with this next one, we again have a few more things going on where we need to get the absolute value by itself to be able to interpret what's going to happen. So I want to move things around in this inequality so that I'm only dealing with the absolute value on the left and everything else on the right. So I'm going to start that off by subtracting 3 here and subtracting 3 here. So I'll end up with 4 times the absolute value of 3x plus 7 is greater than negative 24. At that point, I can divide both sides by 4 to get rid of the coefficient, and I'll be left with 3x plus 7 in absolute value bars is greater than negative 6. Now at this point, I want to stop and think about what we know about absolute values. So if you remember what we talked about yesterday, we came across equations that looked something like this. If I have something in absolute value bars equal to, let's say, negative 10. And what I asked you guys to consider is that if you have an absolute value, you can only ever get out a positive answer. So it's never going to be equal to a negative, which means that there are no solutions for x that can cause these two sides of the equation to be true. Now, if we're talking about inequalities, what we want to consider here, just like with the equation, is that we're always going to get at least 0 out of an absolute value. So it's always going to be 0 or above. If that expression is always bigger than 0, that means that it's greater than negative 6, which makes this a true mathematical expression. And so what that means is that any value of x makes that inequality true. So in this case, we can say all real numbers or all solutions will make that true. So that's one of those special cases. We come across those with equations and inequalities and absolute value equations and inequalities as well.